All right, we are starting chapter 13, which is about trigonometry, which just means we're talking about triangles and math with triangles. So section 13.1 is specifically right triangle trigonometry. So something that should seem very familiar from your geometry days is the Pythagorean theorem, which is the formula that tells us that a squared plus b squared equals c squared. So Pythagorean theorem always has to do with a right triangle. So there's one corner of our triangle that we know is 90 degrees. The two sides of our triangle that make up our right angle, so here that's labeled as side A and side B, those are the legs of our triangle. So you can see it's referred to as side A is a leg, side B is a leg. Side C, the side that's across from our 90-degree angle, is always our hypotenuse. So we can always use a squared plus b squared equals c squared. Anytime I have a right triangle and I know at least two sides of my triangle, I can always solve for that third using Pythagorean theorem. So that's what we're going to do with this first triangle. We've got a right triangle. They've given us that little marking for 90 degrees in one of those angles. They've given us that this side length here is 9. This is one of the sides that make up the 90-degree angle, so that means we have one of the legs of my triangle. And then they've also given us the length that is across from the 90-degree angle, which means we know one leg and one hypotenuse. And what I'm missing is the side of the triangle, the additional side of the triangle that makes up that 90-degree angle. So I'm missing one of the legs. So if we're going to use a squared plus b squared equals c squared, well, right now I pretty much have, you can call this a or b, it doesn't really matter. I'm going to call it b. We know the side across from the 90-degree angle, my hypotenuse is always going to be c. So I just need to plug in those two values and solve for a. So we're going to have a squared plus 9 squared. We know that's got to equal 15 squared. Do some math to simplify. We know 9 squared is 81, 15 squared is 225, and now it's just a matter of solving for a. So I'm going to subtract 81 from 225. We get a squared equals 144. And then we take the square root of both sides, and we get a equals 12. And if you're being super diligent, you might remember that normally we need a plus minus anytime we take a square root in an equation, and you would be correct. But if we're talking about lengths, a length, something we measure, is never going to be negative, right? We don't have negative distances. So in this context, we're okay to ignore the plus minus, and we're okay to just say that that one missing side length of my triangle, or x, is equal to 12. Okay, with my second triangle here, we have been given that this side of my triangle is a length of 3, as well as this side of my triangle is also a length of 3. So I've been given two sides that make up my 90-degree angle, or we've been given two legs of our triangle. And what we're missing is the side across from the 90-degree angle. We're missing our hypotenuse. So again, we can use a squared plus b squared equals c squared. But this time the thing we're missing is our hypotenuse. So if I use that, we're going to say 3 squared plus 3 squared is equal to c squared, or here they're calling that x, so x squared. If I do some simplifying, 3 squared is 9, 3 squared is 9. 9 plus 9 gives me 18. And then take the square root of both sides. We're going to break down my square root of 18. If I come up with any two factors of 18, you could use 2 and 9, you could use 3 and 6. I'm going to use 3 and 6. 3 is prime, 6 is not. Two factors of 6 are 3 and 2. And then I'm just interested in those prime factors. I'll use a different color. And I've got a pair of 3s, so I know a 3 can come outside of the root. What gets left behind is that singular 2. So the hypotenuse length of my triangle there is going to be 3 root 2. Okay, so pretty much anytime we're using the word trigonometry, we're talking about some kind of triangle measure. So we're going to get into our trig ratios. Some of them you've heard before in your geometry classes. Some of them are going to be new. But anytime we're using our trig ratios, we are dealing with some kind of right triangle, because our trig ratios work for every single right triangle. So here we've got a right triangle, and we've got our 6 trig functions. The top 3, sine, cosine, and tangent, those should sound familiar to you from your geometry days. And hopefully what sounds familiar to you as well from geometry is this acronym SOHCAHTOA. Okay, it's really helpful for remembering how to set up our trig ratios if we can understand what it means. And it looks like just this nonsense word. Really, the S here in SO stands for sine, C stands for cosine, and T stands for tangent. And then the rest of the letters are going to tell you how to set up your ratio. So sine of my angle theta, so you can see here they've decided that this angle in my triangle here is my angle theta. Sine is the opposite over our hypotenuse. Okay, so the O in SO stands for opposite, the H stands for hypotenuse. So anytime we're dealing with sine, I'm going to take the length of my opposite side, the side opposite of theta, and I'm going to put that number over my hypotenuse value, the longest side of my triangle, and that will give me the value of the sine of that angle in my triangle. Cosine, okay, cosine of my angle theta, the ka part, the middle part of SOHCAHTOA, the capital A, that stands for the adjacent side. Adjacent means next to. So the side that is right next to my angle theta, that's not the hypotenuse, is this side right here. So my cosine is going to be my adjacent side over my, and then H again still stands for hypotenuse. Okay, tangent of my angle theta. So tangent is O, or the TOA part of SOHCAHTOA, so the O still stands for opposite. A still stands for adjacent, so my side opposite my angle theta and the side right next to my angle theta. So those 3 should sound familiar, hopefully from geometry. It has been a long time since you've had to do anything with this, but hopefully you've learned those 3. It's ringing some kind of bells now. The 3 that are new are cosecant, secant, and cotangent. And they're basically just reciprocals of each of our 3 typical trig functions, sine, cosine, and tangent. So cosecant, which we're going to abbreviate with the letters CSC, is the reciprocal ratio to sine. So sine is my opposite over my hypotenuse, which means cosecant is my hypotenuse side over my opposite. Okay, secant, which we're going to abbreviate with the letters SEC. Secant of my angle theta is going to be the reciprocal ratio of cosine. So if cosine is my adjacent over my hypotenuse, that means secant of my angle theta is going to be my hypotenuse over my adjacent side. And then similarly, cotangent is going to be the reciprocal ratio of my tangent function. So cotangent, we're going to abbreviate COT. And if tangent is the opposite over adjacent, cotangent then is my adjacent over my opposite. As far as remembering which one pairs with which, I don't really have a super great trick for you other than hopefully we can remember tangent and cotangent. Those 2 things sound pretty similar, so those are reciprocals, and typically I don't have issues with people remembering to match those 2 together. But as far as sine and cosine and remembering which one of those is the reciprocal to cosecant and secant, what my trig teacher in high school told me was that one ratio in every pair starts with the letters CO. Again, not a super great trick, but sine doesn't start with CO, so it pairs with cosine, which does start with CO. Okay, cosine already starts with the letter CO, so it's going to pair with secant, which does not start with the letter CO. And then tangent pairs with cotangent. Again, those already sound similar, but the rule still holds in that only one of them start with the letter CO. If you've got another trick, let me know, but that is all I have really been able to come up with so far. But hopefully that helps you remember which ones match with which.